Okay, we are now on the third and last little piece of the skeletal system overview lecture, and we're going to talk about growing some bone. Now, the fancy term for growing bone is ossification. So remember, os means bone. Ossification means making bone. There are two different processes to make bones depending on the type of bone you are making. So the flat bones of the skull and the clavicles too, strangely enough, they are made by a process called intramembranous ossification. So intra means within, right? So inside of the membrane. It's going to be created from a membrane structure that's formed from mesenchyme, which is the embryonic tissue type that forms all of the connective tissues. That hopefully you remember that from the connective tissue lecture. And then all of the other bones, they're going to be created by a different process, which is called endochondral ossification. Endochondral ossification. So hopefully I want you to start thinking of, well, remember, endo means inside. What does chondro mean? Chondro mean, come back to that. Okay, so intramembranous ossification. These are, the skull bones are going to be created this way, and also the clavicles here. And it's called intramembranous ossification, as I mentioned, because it comes from a membrane-like structure that's made out of mesenchyme. Now remember that mesenchyme is the embryonic fetal tissue that gives rise to all of the other connected tissue types. And in that mesenchyme, we have stem cells that will become osteoblasts. Now, what do osteoblasts do? Osteoblasts secrete the organic part of the matrix. And so what they're going to do is the osteoblasts that are found in that mesenchyme, they're going to start secreting the organic part, the collagen, and that's going to be in what we call osteoid. Okay, so this osteoid here is just the organic part of the matrix that contains that collagen. And then what happens is after you lay down the osteoid, that's going to become crystallized from calcium. So the calcium, which is an inorganic mineral, will start to sort of accumulate and crystallize within that osteoid, and that's going to create the bone matrix. And so what's going to happen is you're going to create that nice solid bone matrix around those cells, and the cells that are trapped inside of that solid matrix, now they're living in a little cave, a little space, and that's a lacuna, and they're going to become mature osteocytes. They'll have the little processes that will go out to go into the canaliculi, and that's when you start creating bone tissue with mature osteocytes. What that will then sort of maintain the already established bone tissue. Now, another thing that I find interesting is when you do intramembranous ossification, we're going to create the spongy bone first. So if you remember the flat bones, okay, in the flat bone you have a sandwich. You've got on the outside you have your compact bone, and then in the inside we have the spongy bone. So that bone tissue is going to start creating trabeculae, which are just the columns of bone within the spongy bone. And then they're going to start creating compact bone on the outside. Okay, so we have the spongy bone kind of sandwiched in the middle, and then compact bone is going to form on the outside, and that's how you're going to grow and create those flat bones of the skull. Now, one thing that I'd like you to note is at birth, this process of growing those skull bones is not fully done. What I mean by that is instead you have plates of bones intact, but you'll have soft spots between them that are not ossified yet. They're not fully bone tissue there. And those soft spots have a name, and they're called fontanelles. So the fontanelle is just the soft membrane structure that's in place before the bones fully come together. Remember, they're going to come together and create a suture. Okay, so those are fontanelles. Now, I did want to take a minute and mention that this picture right here is a bit concerning to me because fontanelles that are depressed like that, kind of sucked in, that might indicate dehydration. So this picture is worrisome for me. Okay, anyway, back to the lecture. So fontanelles. So one question I had to ask for you is, well, why would we be set up in such a way so that our skull bones aren't fully grown by the time we're born? That seems odd to me. And if you think about it, is that those membranes, which are soft, they're going to allow for a lot more movability, flexibility, right? And so as the baby's head is like making its way through the birth canal, it allows for a little bit of compression so that it's easier to come out. And then the second thing is within those first 2 years of development, the brain is going to grow very, very rapidly. And you never want to put pressure on the brain. That'll damage the brain tissue. And so to allow for a little bit of breathing room, the fontanelles are going to help sort of give some extra space in there, some flexibility so that the brain is not going to be damaged as it's growing very rapidly. Okay, so pretty nice thing. So not fully ossified at birth so that it can fit through and to allow the brain to grow. Okay, so that was the first one, intramembranous ossification, which just means from within the membrane, right? So it's 4 membrane structures. Now we have endochondral. Okay, so endo means inside. Chondral, as in chondro, is what? What is that? You've seen those before. That means cartilage. Okay, so instead of creating bone tissue directly from the fetal mesenchyme, instead what happens is the fetus is going to create a template, a mold, that's created out of hyaline cartilage. Okay, so it's chondral ossification because that's related to making the hyaline cartilage first and then filling it in as bone, right? So you make a little mold, a little template using the hyaline cartilage, and then that's going to turn into bone. Okay, so again, this is all of the other bones beside those skull bones and the clavicles there. So here's how we have. So at this point, we have our hyaline cartilage that's made the little template. And then the first thing that's going to happen is we have what's called a primary ossification center and in the inside. And then on the outside, we have a connective tissue layer called the perichondrial. Don't need to know that one. And that actually has osteoblasts in it. And what do osteoblasts do? They lay down matrix of the bone. And so what happens is you get what's called a bone collar. And the bone collar just refers to there's compact bone created around the outside, the diaphysis of that bone. Okay, so here's the bone collar right there. And that's where you have the very first part of the bone created. And then what happens is when you create that bone collar, it makes it so that the chondrocytes, which are the cartilage cells inside, they're not getting what they need. And so they start dying off. And so they have this calcification inside and it starts deteriorating. And what do you think that's starting to form right in there? What's inside of those long bones, right? That's where you start getting the medullary cavity. So you start hollowing it out on the inside. And then the next thing that happens is you just start creating a blood vessel that goes through, right? So the blood vessels are going to penetrate through that bone collar, and that's going to provide nutrients and oxygen to that area inside. But what comes with it, right? So that's called the periosteal bud, as in like the bud of a flower. So we have the periosteal bud where we have that blood vessel penetrating in and sort of invading into the inside of what will become the bone. And what it brings along with it are more osteoblasts and osteoclasts. And so those osteoblasts are starting to building up new bone tissue. And then what's going to happen is they're going to reform that what was cartilage now into spongy bone. So you'll have what becomes your medullary cavity, and then a little bit of spongy bone on the outside. And remember, you already had your compact bone collar on that side. So now you're starting what looks a lot like the diaphysis, all nice and fully in place. Now, we still have to look at what happens in the epiphysis. So around birthing time, so please note that that's kind of strange because, you know, by birth, you still have a lot of hyaline cartilage in those bones. It makes it a lot more flexible, by the way. And inside we have now what's called the secondary ossification center. So the primary ossification center would be in the middle of diaphysis. The secondary ossification center, those are going to be in the epiphysis. Okay, so one on each side, and basically they're going to do the same thing that we already saw before. It'll be invaded by blood vessels. Those blood vessels will bring in with them osteoblasts, osteoclasts. You'll do bone remodeling, bone growth, bone development, and you'll end up with a bunch of spongy bone inside of those epiphysis, right inside of there. Okay, now we do have some hyaline cartilage still left over. So by the time that you are from child all the way to you are full grown, you're going to have two structures. The first one is the articular cartilage, and the articular cartilage is just a little cap of hyaline cartilage that goes over the top of the epiphysis. This is going to be where joints happen. And then the second place is an articular cartilage remains for the rest of your life. You always have those articular cartilage. The second place where you're going to have a little bit of hyaline cartilage is what's called the epiphyseal plate. And the epiphyseal plate, that is where bone is going to grow as you grow up, right? As you go from a child to an adult, this is where the growth is going to happen. Okay, so looking at this picture here, this is just a picture where you can see through an x-ray, if you see this line right here, the reason it looks different from the rest of the bone is because it's not bone. That is going to be the hyaline cartilage, and this is the location where this bone here, in this case the tibia, is going to grow up. One thing I think is very kind of bizarre and awesome and interesting is that when you look at how the bone grows, it actually will grow towards the shaft, not from the bottom. Okay, so the growth is going to happen towards the diaphysis. And if you look at that in the microscope, this is what it looks like. So this part right here, that's bone. This would be, oops, wrong direction. This would be this part of the epiphysis, so like the end of the bone there, and it's going to grow towards the diaphysis. So this would be the epiphyseal line, epiphyseal side, and the diaphyseal side right over here. So here we have our normal bone, then we have a plate of hyaline cartilage. This is what's called the resting zone. And it's called the resting zone because it's just hyaline cartilage doing its normal thing, just resting. And then next to it here, what happens is those chondrocytes, which are inside of their own little lacuna, those are the chondrocytes, they began rapidly dividing. So they're going to undergo mitosis and make a bunch of chondrocytes. And so you see how the chondrocytes are all stacked up on top of each other like that? That's because they're rapidly dividing. And as they're dividing, they're kind of pushing everything down. And that's how you're adding the material that will make the bone. And that's called the proliferating zone because they're proliferating, they're making more of them. And then the next part that happens is those chondrocytes change. They actually grow bigger. Okay, so those are going to be in what's called the hypertrophic zone. So trophic means growth and hyper means above, right? So grow more than. And that's what's going to cause them to get really big. See how they're getting really big? And then once they get really big, they start making calcification. So what it means is the matrix becomes calcified, okay? So once it becomes calcified, those chondrocytes are not going to be able to get what they need. No oxygen, no nutrients. They start dying off. And then what happens is now we're in the ossification zone. So what does os mean again? Bone. Okay, so what happens is those chondrocytes will die off, and now we've got our osteoblasts, and the osteoblasts are going to do what osteoblasts do. They're going to create and make the bone tissue. Okay, so I just wanted to sort of really highlight how the way that this growth is kind of strange, right? So here's your epiphysis here. There's your diaphysis there. Your epiphyseal plates will be right kind of at the boundary, at the sort of in the middle where the epiphysis is. And what happens is as they grow, right? So on this side here, we'd have bone, then we have our normal hyaline tissue, and they're gonna grow this way, right? So the new bone will be added in this direction. And so they're gonna be growing towards the middle instead of coming out of the ends, right? So it grows like that. And that's gonna lengthen those bones like that. And if you think about it, that makes a lot of sense. If you look at like how children look, right, with their knobby knees and everything, and it kind of just lengthens out that way, especially toddlers. My son's doing that a whole bunch right now. It just sort of lengthens out as it grows towards the middle like that. Okay, so once they are fully grown, this epiphyseal plate will now become closed. And what we just mean by that is we're not making any more cartilage. It is now closed. We've got all the bone that we're going to have. No more growing happens there. And once that happens, it's then called an epiphyseal line instead of a plate, and that means that it's fully grown there. And that brings us to a little bit of pathology, achondroplasia. Okay, so remember, if you see the word, then the letter A at the beginning of a word, it just means you're missing whatever comes after it. In this case, chondro means cartilage. And so achondroplasia, what happens is that you have some sort of disorder, it's a genetic mutation, where you have defective growth of the cartilage. And if you can't grow the hyaline cartilage, you can't make the bones from this. And this is especially evident in the long bones, because the long bones are going to have those epiphyseal plates that grow until you're like 25. And if you can't lay down the hyaline cartilage first, you can't make the bones grow. Okay, so what happens is you get early closure of the bone into lines, early closure of epiphyseal plate into an epiphyseal line. And once they're closed, there's no more growth, right? So you end up with that shorter stature. And again, it's specifically affecting long bones, not really the skull, because the skull is going to be made of a different process. It doesn't involve hyaline cartilage, it's the intramembranous ossification. And that's why you tend to have like normal sized skulls, but the long bones and the rest of the body are the ones that are going to be affected. Okay, so key point here. For endochondral ossification, you make hyaline cartilage form first, and then you turn that into bone. Okay, bye-bye.